everyone. So what we're going to be talking about today is balancing chemical equations. And so we started off with Sudoku because Sudoku is a puzzle, just like balancing equations will be a puzzle. But it's my favorite type of puzzle that you can do, is balancing equations. So it says in every chemical equation there are reactants and there are products. And the reactants are the substances that are changing into one or more new substances. And once they change, we then call them, instead of being called the reactants, they're now called the products. And an easy way to remember is RAP, R for reactants, A for arrow, and P for products. Okay, now the arrow takes on different words. You'll see things like, anybody want to guess at some of the words that they use for the arrow instead of using the arrow?
Yield.
Yields is one. They'll say to produce. They will say decomposes into. They will say creates. Something like that, or is synthesized to form, something like that. So you'll have different words for this arrow, and you'll get used to it as you see more and more problems. But just making sure that you remember that the reactants are what you start with and the products are what you end with. Okay? You'll see that there are numbers written in front of a substance. Anybody know what those numbers are called? Starts with a C. Coefficient. Awesome. The number is called the coefficient. And the coefficient is going to be the only thing that you are allowed to change once you have your formulas correctly written based on our nomenclature. We went through the naming rules. Once you have a formula set and it's named properly, you can no longer change the subscripts. The only thing you're going to change is the coefficient, which is the number in front. And what it tells you is it gives you the ratio of the substance in the reaction. You must have the same number and kind of atoms or elements on both sides of the equation. So anybody know what this law is? It's called the law of conservation of matter. Awesome. The law of conservation of matter. What this basically tells us is if you start off with some carbon-hydrogen compound, maybe you have something like sugar, and you're going to burn the sugar. So let's talk about a little bit like cellular respiration, like maybe if you remember this from bio. And so you have C6H12O6 or glucose, and you burn it in oxygen. You combust it with O2, with oxygen. Anybody know what two products you get when you have C6H12O6 plus O2? There are two products, and I'm going to give you a hint. It's made of CHO and O. So it's a rearrangement of carbon, hydrogen, and oxygen. Anybody know what you get when you burn any of the, and this happens when you burn alcohols, when you burn methane, propane gas, anything like that. Give me any formula. One of them has a C and an O in it. CO2, carbon dioxide, and H2O, water. If you remember from your bio class, I know it was a while ago, but sugar plus oxygen will give you water plus CO2 plus what? Energy, ATP. Do you remember this?
Yeah.
Does this look a little bit familiar? So you can go either way. It's either respiration or it's photosynthesis coming back. Do you remember how then with the sunlight versus energy being stored? And so what we end up having is we have the sugars. Now you can see that it's plus O2, but there are 6 O2s. And then it yields 6 CO2s and 6 H2Os, but there's only one of these. And the idea is they have to be balanced on both sides. So whatever comes in must come out. You're not going to have a new element. It's not like nitrogen's just going to be thrown in there. It would have to be on your reactant side in order to show up on the product side. But basically all that happens is you rearrange all of these atoms. And instead of having sugar, the sugar is now burned, and instead of having sugar, now you've made carbon dioxide and you're left off with water. Now there are byproducts, okay? So when you burn sugar, you're going to get byproducts. But this is what are the major compounds that are inside of this reaction, that are taking place, that are rearranging in this reaction. Okay, so if a reaction is written unbalanced, then it is called anybody know starts with an S? It's like you without your skin and without all of your organs. It's called your skeleton. Very good. It's called the skeleton equation. So for example, if I just wrote C6H12O6 plus O2 yields CO2 and H2O, then that would be called the skeleton equation. Okay? It's not balanced. I don't have the same number of carbons on both sides. I don't have the same number of hydrogens on both sides. Okay? And you start off by writing this down. What we're going to be doing in the next unit is we're going to predict products. So what's going to happen is I'm going to give you two reactants and you're going to tell me what the products are. So we'll talk about this. I have a way of memorizing the hydrocarbons burning. I say reacting O2 with Cha or Cho always produces Co and Ho, Co and Ho, Co and Ho. And so there are different reactions that we're going to talk about. It works in nature, but we need to make sure that we remember some of them. Some of them are memorization and others, it just kind of works like a puzzle also. So I've got some rules, but I'm going to cross this off. They're not really rules. These are actually my tips. Okay? These are my tips. What happened was when I was learning how to balance equations, my teacher said trial and error. He said the rule is you have to have the same number of atoms on both sides of the equations. Go. That was it. Okay? And what I did was I started trying to figure out what some things were to speed me up. Because there will be problems that will take you 20 minutes, okay? And we tried it in second hour, and there's only one person that got it in under 4 minutes. And then everybody else, like, never got it, okay? And it could take you 20 minutes. So I want to make sure that we go through these. If you follow my tips, then nothing should take you more than 2 minutes, okay? If you don't have the tips down, now I'm fast at it, so I have the tips memorized already. They're my tips. But if you don't look at them, you could take a really long time. The first one is only change the coefficients, meaning you can't change anything but the number in front. Once you have your formula written, that's it. You're going to start with the most complex reactant. What I mean by that is ternary is you would start with first, then binary, then diatomic, then single atoms. For example, something like calcium phosphate, Ca3PO42, would be considered a ternary one. And then if I wanted binary, then binary would be something like Ca3P2. Why is that binary? It's only made of 2 elements, binary meaning 2 elements. Diatomics, the diatomics are the Brinkelhoffs, right? So Br2, I2, N2, dot, dot, dot. Okay, all of the diatomics. And then single atoms would be just something like sodium, or maybe you just have something like sulfur, maybe you just have something like magnesium. Those would be single atoms. You're going to want to start with the most complex, okay? And not only the most complex, but the most complex reactants. And where are the reactants with respect to the arrow? To the left or to the right? To the left. Perfect. If there's the same polyatomic on both sides, balance it as a bag, okay? If you see a polyatomic ion and it has to exist on both sides, you're going to put it in parentheses. So for example, if you see something like KOH and on the other side you have something OH, put it in a bag. Don't do the O and the H separately. Do it as OH as one unit. Okay, this is the save it for last rule, and this is huge. This gets 3 stars. So this is the save it for last rule, and the save it for last rule is, if you have something like, do you see how there's oxygen, 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 oxygen? Mm-hmm. If you try to balance the oxygens, you will take a really long time, because you change one, and then another one changes, and then another one changes, and then you're like, I don't even know what to do, it keeps changing. So if you see it and it appears in more than one place, then save it for last. Usually you will not have to touch it, it will fix itself by fixing the other ones, okay? So I'll explain that later. The odd to even rule gets 2 stars. This is huge. By multiplying by 2. If you get an odd, change it to an even. So if one side's odd, one side's even. If they're both odd, fine. If they're both even, fine. But if one's odd and one's even, change your odd to even. And this is going to help tremendously also. Okay? Water. This gets 1 star. The water rule is also really important. I've seen people spend a really long time trying to balance an equation. And all you have to do is, now it only works if you have H and OH on the other side. So if you have a reaction that has something like NaOH on one side and then on the other side, and you've got like maybe like plus H2 over here, and on the other side you have something like H2O plus Na, then what you're going to do is, you see how there's an H and there's an OH separately? What you want to do is you want to change water to HOH, and it's going to speed you up. Okay, so that's the change water to HOH, and I'll show you how that works a little bit later also. Having patience is the key. Think of these as brain teasers. If you have a process, they come quickly though, okay? So the first thing is, let's just do our diatomics real fast. And you do want to make sure you go through your naming rules. If you don't remember your polyatomic ions, please pull out your polyatomic ion sheet so that you have it nearby as well, okay? For a little bit later. So what are the diatomics? It's Mr. Who? Brinkelhoff. So write that down. Don't look at mine. Try to write it yourself. So Brinkelhoff. And you should fill in all 7 of those lines. All right, let's try it, okay? So there are multiple ways to do these. My way, I feel, is very fast. What some people will do is they will inventory. So they'll write down what elements they have on either side. So they'll write Zn, H, and Cl. Zn, H, and Cl. And they'll say how many they have on either side. So 1 Zn, 1 H, 1 Cl, 1 Zn, 2 H's, 2 Cl's, and then they'll start changing things. Yes? You've seen this before? So, possibly in the video that you watched. So, I'm going to do this a little bit differently though, okay? I'm going to start with the one that's more complex. Which one's more complex, has more elements in it? HCl. That's where we're starting. You're going to check to see how many H's are on this side in comparison to your product side in total. So I've got 1 H here and 2 H's there. So what do I need to do to this one? Put a 2. You do not put a 2 there. You do not add a subscript because this formula was balanced because it's hydrochloric acid. H has a plus charge and Cl is a minus. It does not work as H2Cl, so you can't do it that way, okay? You put the 2 in front on the line, okay? So that's 2HCl. Now what just happened, it's going to be like playing tennis, okay? So now the ball's here. I just changed the H's, so now I've got, I'm sorry, I changed the H's, so now that affects my Cl's. So I've got 2 Cl's and how many Cl's here? 2, so that's fine. 1 Zn, 1 Zn, and I'm done. Let's try the next one. Pretty easy? Okay. HGO, I only have one reactant, so I have no choice. 1 Hg, 1 Hg. How many O's on this side? 1. And on this side I've got 2. So what do I want to do to this one? Change it to a 2. But that changes my Hg's. So now how many Hg's here? 2. And that one's done. Pretty easy. Let's try the next one. I only have one reactant, so again I have no choice. I'm just starting here with the KClO3. 1 K, 1 potassium, 1 potassium. 1 chlorine, how many on this side? 1. 3 oxygens, 2 oxygens. What do? Change odd to even is the rule, but you could also say, well, what's my least common multiple between the two is? 6, right? Between the two, so I want to multiply or factor between the two. So I would do this one times 2 and this one times 3. So odd to even, I would double this one and make that 6, and then times 3 to make that one 6. But what did I just change? The K and the Cl. So now how many Ks do I have? 2. And then that makes it 2 Cl's. Don't forget to distribute. And that's 2 Cl's also. So now that one's done. Let's try the next one. I'm seeing polyatomic ions. If the same polyatomic ion, and only if the same one appears on the other side, put it in a bag. Do you see the same one? Which one? NO3 here, nitrate, and nitrate right there. What else do you see? CO3. CO3 there and CO3 there. Just put it in a bag just so that you can keep it separate. You don't have to do those separated now. You can just do them as one unit. I've got, it doesn't matter which one, because these are both ternary, so it doesn't matter which one we start with. 1 Ag, 2 Ags. What do? Put a 2 in front. Again, you can only change the coefficient. How many NO3s now? 2. Remember, that distributes, so I've got 2 of these. And on this side, I only have 1. So what do I need? A 2 in front. That just changed my NA. So again, it's like playing tennis. Now the ball's here. So I've got 2 NAs, so come back to this side. How many NAs here? 2. 1 CO3, 1 CO3, and we're done. Okay, last one of these. I've got 1 cobalt, and over here I've got 3 cobalts. So what do, I don't have bags. PO4, let's put it in a bag. And let's put the nitrate also in a bag, because I see the other one on the other side. So 1 cobalt, 3 cobalt. So what do I need on the left? 3. A 3. Be careful. How many NO3s do you have here? 6. These get multiplied together, okay? So make sure you put it in a bag. Otherwise, you don't want to be multiplying like by a 4, for example, over here. There's only 1 phosphate. So that's 6. So on this side, on my nitrates, what do I need here? A 6. That makes it 6 NAs. So what do I need? If I've got 3, then I need a 2 to make that 6. And now I've got 2 PO4s and 2 PO4s, and it's done. This is the one that I was kind of like stirring because I was pre-student teaching, and the teacher said, let's work this out. And they separated every single element, and it took them forever. And I was like, nah, why are you teaching it that way? Okay, everyone go to, I'm going to time you. Everyone go to the packet. All right, so for number 9, I've got 1 N, 1 N. So that's fine. I've got the 3 H's and the 2 H's. So a 3 and a 2, I'm going to change my odd to even. So I'm going to make this one a 2, and that makes it 6, which means I need a 3 there to make that 6. My N's are now just changed. So now I have 2 N's, so I need a 2 in front of that one. My N's and my H's are now fine. How many of you got to this point and were like, yes, I'm so close? You are so close, okay? So this last step can be really, really easy. Okay, watch this. So I count my O's, and on this side I've got 2, and on this side I've got 2 plus 3, which is 5, okay? The rule is, if you have an even on one side and an odd on the other, you change your odd to even. How do you do that? Double it. So instead of this being a 3, I'm going to make it a 6. But because I did that, now that changes this, and I have to double this also to a 4 because my H's were 6 and now it's 12. That changes my N's to 4, which means I also need to double this so that now I have 4 N's. Now, let's check the O's. Everything else is balanced. I've got 2 O's on this side, and here I have 4 plus 6, which gives me a total of 10 total oxygens. So on this side, how do I make that 10? 5 times 2. You want a faster way? Yeah. Okay. Here's the faster way to do it. I like the odd to even rule. That makes it really quick, but watch this other way of doing it. So let's get back to where everybody was before, where they said, okay, I've got this, I'm really close, I just need my oxygens, okay? So you're here. We've got 2 oxygens and 3 oxygens, which gives us a total of 5. That means that I want this to actually be equal to 5. What times 2 equals 5? 2.5? What's wrong with writing 2.5? These need to be whole numbers. It's the lowest whole number ratio between them that's equal. How can you make that a whole number?
Multiply everything
Multiply by 2, but if you multiply this by 2, you need to multiply everything by 2. So this becomes a 4, that becomes a 5, that becomes a 4, and that becomes a 6. Doesn't matter which way you do it, either way will get you the right answer. But if you try to do it another way by trial and error, you could take 20 minutes, and that's what I want you to avoid. All right, so what we're going to do now is we're going to actually write the formulas out. So this is just a quick review of polyatomic ions, but for now, use your polyatomic ions again so that you can get used to them again. So have your polyatomic ion sheet, it's going to help you, okay? Molecular formulas, remember, the prefixes tell you how many of each atom you have, and you don't reduce them. So for example, what is dinitrogen tetraoxide? What would that be? N2O4. Awesome. Ionic formulas. Remember, you have to write your charges up and crisscross. If you don't do that, you're going to get the entire balancing wrong. Your coefficients will be wrong just because your formulas are wrong. So for example, calcium phosphate. Calcium, you would find on the periodic table, has a +2 charge. And phosphate is PO4, put it in a bag, with a -3 charge. So what do I do with the 2 and the -3? I crisscross and get a 3 and a 2, okay? So if you wrote CaPO4, then it would be wrong because when you inventory that, you would have, instead of 3 calciums, it would be 1. And instead of 2 phosphorus, it would be 1. And instead of 8 oxygens, it would be 4. So make sure that you get your formulas right, okay? Acids. Remember high Titus in the adic? So, for example, phosphorus, OUS would change to ite. What do all acids start with? H plus. Good. And then if it's phosphate, phosphate is PO4, so phosphite is PO3. Good. With a -3 charge. So it'd be H3PO3 when you crisscross it. Okay? So just make sure that you get your formulas right, because otherwise your whole balancing will be wrong. So let's try some of these. Iron reacts with oxygen. What's iron? Fe, we're going to write a little coefficient line in front of it. Reacts with would be a plus sign, oxygen. What's oxygen? Not O. O2. Write your coefficient line in front. To yield. What do you think to yield is?
The arrow.
The arrow. Iron 3 oxide. So it's Fe, and the 3 makes it a plus 3 charge. And what's oxide? Not hydroxide, just oxide. O with a negative 2 charge. And when you crisscross this, you get Fe2O3 and put your coefficient line in front. Now, once you have your reaction written, do not change any of the formulas. I'm going to change colors. So maybe in pencil you do this in pen, and then in pencil you do your balancing. Remember, which one's more complex? O2. So I'm going to start with O2, and here I have 2 O's and 3 O's, so what do?
Multiply.
Multiply the odd by 2, so I'm going to make that one times 2, which means that equals 6, so then to make this 6, I would multiply it by 3. Now that changed my irons. So my irons, I now have 2 times 2, which is 4, so how many go here?
4.
Okay, let's try the next one. So it says that hydrogen peroxide, H2O2, decomposes into, what do you think I need? An arrow. Don't forget your coefficient line. Into oxygen gas and water. What's oxygen gas? O2. And water is H2O. Now, water rule. The water rule is change H2O to HOH only if there is H and OH on the other side. Only if there's H and OH. I'm not going to change it because I don't see an OH. There is an H, but I don't see an OH, so do not change it. Okay? It'll take you longer if you do it the wrong way. So I've got 2 H's, 2 O's, save it for last, but I did save it for last. I have no other options. So 2 O's, and on this side I have 3. What do you do when you have 3 on one side and 2 on the other? Odd 2, even. So let's change the odd, which is the 1, changes to an even by multiplying it by 2. So I'm going to do a 2 there. And when I do that, that makes it 4 H's. So then over here, how do I make this 4 H's? Multiply by 2. And now I've got 4 O's here, and then 2 plus another 2 gives me 4. Okay, let's try one with water that doesn't work out that way. So I've got water reacts with H2O plus sodium is simply Na. To produce, what is to produce? Yields. Arrow, good. Hydrogen gas, which is just H2, plus sodium hydroxide, which is Na with a plus 1 charge, and hydroxide is OH with a negative 1 charge. Put it in a bag. So it's a 1 and a negative 1. So those cancel out anyway. All right, I see water on the left, and I see an H and an OH on the right, which means I should change H2O to what?
3.
HOH. You could balance it the other way, it'll just take you longer, okay? So let's work it out now. I've got 1 H there and 2 H's there. I'm treating my H separately from my OH's now. So what do I need on the left? A 2. So I need 2 H's there. Now I'm going to distribute, and now it's 2 OH's, and on this side I only have 1 OH, so what do I do there?
2.
Put a 2. That makes it 2 NA's, and over here I only have 1, so then I need 2, and now it's done. Okay? And then the last one I want to do is this one right here. Magnesium hydroxide decomposes. It's Mg plus 2, and hydroxide is OH minus, so it's MgOH2. And it's decomposing into magnesium oxide, which is a 2 and a negative 2, which means they cancel out. They balance out. And water, H2O. Watch what happens here. 1 Mg, 1 Mg. Why am I not going to do my O's right now? Save it for last. Okay? By the way, I'm not going to change my water because there's an OH, but there's no H on the other side, so don't change it. I've got 2 H's, 2 H's, 2 O's, 2 O's. It's already balanced. You wouldn't do anything to it. It's already done. Okay? And that's it for balancing equations.